Okay, so last week we went over basically essentially what synthesis is in a theory aspect. What are the different parts of a synthesizer? What are the main terms used for synthesis and all that? This week I kind of want to get into actually working with a synthesizer. Last week I just showed you all the different concepts, all the different ideas. This week we're getting into the meat and the bones of it. We're going to actually open up a few different synthesizers and start going over the very basic concepts, like the very basic types of synthesizers. So the first type of synthesis that I want to go over is subtractive synthesis. And fun fact, if you've been following these lectures, we've already been going over subtractive synthesis because it's the most popular and the most well-known form of synthesis really used. And it's essentially the concept of an oscillator going into a filter and then being amplified. That's really what subtractive synthesis is. There's nothing else to it, but let me go a little bit more in depth of what exactly we mean when we're saying this. Taking something harmonically rich and removing content from it. So what we're doing is we're taking a signal or a waveform that has a lot of harmonics on it. It's very harmonically rich. It has a lot of representation across the entire frequency spectrum, but still has tonal content, so it's not just noise. So it has some kind of tonal aspect to it, very harmonically rich, like a saw wave. But it doesn't have to be a saw wave, but just for example, since the saw wave is very harmonically rich. And we're going to take that huge band of frequencies that it has, and we're going to take away from it. We're going to subtract some of those frequencies away from it. So we take this very harmonically rich thing and we are sculpting it in the way that we want it to sound with those harmonics. So essentially we just have this huge waveform and we're just going to sculpt in and out those frequencies that we want. It's also called subtractive synthesis because you could say that with the envelopes that we are subtracting volume over time if we're having it fade in or fade out, when it's just like a regular signal that's amplified the whole time, if we're going to be fading it in, fading it out, that's subtracting away volume as well. So you can talk about it from that aspect too, but mostly people will talk about filtering or EQing, I guess, if you want to call it that, but filtering out different frequencies over time. So if you take a look at this example, it's kind of like wood carving. We take something and we remove aspects from it. We start carving away those aspects to get what we want, to get the sound or the image, or in this case, the sculpture that we want out of it. We're taking something and removing from it to get the sound that we want. That's basically what I've taught so far. This is what I taught last week when we started doing synthesis. It just has a name. It's called subtractive synthesis. And you'll notice right here, I want to talk about something before we actually jump to a synthesizer, which we're about to do already because I've already gone over most of the concepts already. We're going to talk about essentially what on the filter a resonance is. So there's different parts of a filter and we'll get to it, but the resonance factor on a filter, so say this is a low pass filter, as you can see, if we added resonance to that, so this point right here, let's talk about this point right here where it starts to go down is called the cutoff point. So you'll see that on a bunch of different synthesizers, this is called where on the synthesizer it is called the cutoff point. And sometimes it'll just be like, oh, what frequency do you want? And that frequency is going to be your cutoff point. And you can have it reverse the same way too, excuse me, if you were doing a high pass filter. So this is your cutoff point. But at the cutoff point, you can do this thing called adding resonance, which essentially amplifies the cutoff point a little bit. And I'll show you what that sounds like, but I wanted to show you what it looked like first so that you understood what was happening. So it still has, we're still cutting off those frequencies, but we're just going to boost these frequencies right at the cutoff point to accentuate them before they get removed. And I'll show you what that sounds like in a second. So we're not that far into this lesson, and we're already going to be jumping into working with the synthesizer. So this is Reason. It is a different kind of digital audio workstation, but it allows you to work with this rack. You can see it's called a rack. And up here, you can see I'm going to be, playing notes in on the keyboard because I don't have my keyboard with me. So I'm going to be playing notes on the keyboard, but you can see what they are here. So how this is going to work is I'm going to bring in a very basic synthesizer. This synthesizer is called Monotone. It is a synthesizer available with Reason. And the first thing that I'm going to do is I'm going to reset this synthesizer because it already has a patch on it. This is what it sounds like. I'm going to reset the synthesizer, which I can do by right-clicking and going to reset device. You can see right here is the name of the patch that we're working with. It says init patch, and a lot of times you'll see synthesizers use the term init. It means initial, short for initial patch. So it's essentially the first basic patch. Before we actually work with this, I'm going to modify it a little bit so that it actually kind of sounds like an initial patch. I think I've got everything that I wanted to change. I'm probably forgetting something, but let's take a listen to what the synthesizer sounds like. So right now, yeah, let's just play it. Let's just play with see what it sounds like. Yep, sounds like a synthesizer to me. Before we actually start working with the synthesizer, there's a fun thing in Reason where you actually, since this is a rack, there is a backside to the rack. And if you hit tab, you get to see all of the wiring that's going on in the back here. So what I'm going to do so that we can visualize this a little bit more is I'm going to take this oscilloscope, and I'll explain what that is in a second. I'm going to run the output of the oscilloscope into the audio in, and then we're going to remove that because we're just doing a mono thing, and we're going to do the audio through and send that back into the mono input of the mixer. So we turn them back around, nothing's changed. But if I say that this is audio now, we get a signal. So I'm going to change this slightly a little bit so that we can get like a better idea of what this is going to look like. Okay, so you can see down here we have what's called an oscilloscope. And it's not the best oscilloscope, but it's a free one that I could get that worked in Reason. So what it is it shows you the oscillations of the waveform. So right now, you can see that we're working with a saw wave because it is shaped like a saw. It ramps up, and then it goes immediately down. So let's get into working with this synthesizer Monotone. So some things that you should know about Monotone before we work with it. It is a mono synth. That's why it's called monotone. It is a mono synth, which means that it can only do one voice. So if you take a look up here, I'm playing C, but if I decide to play a D while holding on, or let's say I try playing a chord, you'll notice that I can't, I'm playing multiple notes at once, but I cannot play a chord. That's because it only has one voice. It can only do one note at a time. So you'll notice that when I change the note, it's going to jump to that next note. So I can't play chords with this kind of synthesizer. And I can't change that either. It is just a monophonic synthesizer because it's made for basses. And if I put it down to where it started, it would actually be like down here. But I want it to be like a little bit more audible. Work in a frequency range that we can work with a little bit. So we're going to ignore this first section, but you can see that the synthesizer is laid out pretty simply, actually. We have the oscillator section right here. We have the filter section, the amplifier section, some effects that we can add that are built into the synthesizer, LFO, and envelope. So we went over the basic layout of a synthesizer last week. So the notes that I'm sending in are going to be sent to the oscillator. So we have two of them here. We have one on this side and one on this side. The oscillators are then going to go through a mixer. So where's the mixer on here? Well, that would be this little knob right here. Remember, sometimes I said if it's just two oscillators, it's just going to be a knob. So this side over here is an oscillator. This side over here is also an oscillator. So you can actually mix between how much wet and dry you want of one or the other. And that's your mixer. And then I said it would go into the filter. Now the filter, as we said, is something that sculpts the sound in terms of frequency. That's what subtractive synthesis is. It has a filter. And then it goes into the amplifier, excuse me, which will change the amplitude over time. So it's going to subtract, fade in those sounds over time. You can see we have our ADSR. And then we've got some effects. And then it's going to go out to the, out the amplifier and go through the rest of Reason here, be processed into what you're going to hear. So let's work one part at a time. So we're going to work with this is a very basic synth. We're going to move on to a little bit more complicated synth in a second. But let's just get the basics down first. So we talked about oscillators. Oscillators is the device on your synthesizer that is essentially creating the oscillations, that's creating the sounds that you want. So we have two oscillators here. We have one on this side, which has two knobs, and one on this side that has the same two knobs. Well, I'm just gonna tune that, just make these the same. So you can see we have our four basic wave types here. We have our saw wave, square wave, triangle wave, and sine wave. Those are the four wave types that we went over last week. So we have our sawtooth, square, triangle, and sine wave. And here we actually have a parameter in which we can control which octave that is in. So we can make it, let's make it a little bit, let's turn it back to the saw wave. We can make it a little bit, we can make it average, like middle of the road, make it a little bit lower, even lower if we wanted to. Or we can make it higher, or even higher. So we have a lot of range over what octave we want this to be. So I'm going to put it right here so we can hear it a little bit better. And we have the same control over here. So I'm going to set this one to be a square wave. And you can see we have the mix knob here. So one is playing a triangle wave. The other one's playing a square wave. Actually, it looks like it's a different type of square wave over here. Let's actually change to a triangle wave so that we have a sawtooth wave, triangle wave, and then we have this mix knob. So you're going to see down here that it's going to change from a sawtooth waveform into a triangle waveform over time. And that's the mixing that we do. And this is both of them. This is what the waveform would look like. So the triangle wave, or sawtooth wave. So we can mix how much of one or the other that we want in. But let's just stick with one oscillator for now. So this is basically all the controls that we have for our oscillators. We don't have really too much other than what waveform that we can pick and what octave we want and how much between these two that we can mix. I'm actually curious, is this a slightly different square waveform? Yes, it is. It's a different type of pulse. You can see. So let's move on to, so we went into the oscillators, into the mixer, so then we're going to go into the filter. So you have the filter here. I'm not going to go over all of the controls here immediately, but I do want to go over a couple of things. So let's talk about this knob. So this is our filter, our frequency knob, or what you might consider the cutoff frequency. And you can see that Reason is actually conveniently telling us what frequency it's cutting off at. This is actually a low pass filter, and we cannot change that. We can't make it a high pass filter or any type of filter. It is just a low pass filter, but we can see at what frequency we are cutting off. So right now we're cutting off at 6.89 kilohertz, or 6,000, almost 7,000 hertz. And after that, the frequency is going to be reduced. So above that, frequencies are going to start being reduced. So if we go all the way to the top here, and we start reducing it, well, you get to hear how it becomes less harsh and a little bit more mellow as those higher frequencies get removed over time. So that's essentially what we're doing with the filter. It's essentially a high pass or a low pass filter. Sorry, a low pass filter in which we are removing frequencies to essentially shape it how we want to. We are subtracting the frequencies we do not want. Subtractive synthesis. So we're subtracting away those frequencies. I went over the resonance, and remember that the resonance is a raise in amplitude at the cutoff point. So if the cutoff point is right here, 4.72 kilohertz or 4,720 hertz, at that point, there's going to be a bump in amplitude. So instead of a reduction of amplitude past that point, there's actually going to be a slight boost at that point, and then it's going to go down. So this is what happens when so this is our synth as is. Let's see what happens when we raise the resonance. You can hear at about 4,000 hertz, we are getting a bump in frequency. So the sine waves around that point are getting a bump in frequency. So let's start to sweep through our frequencies now that we have a little bit of bump at our cutoff points. Let's start high. You'll notice that it has kind of a different sound to it as we filter through. So this is without the resonance. And this is with the resonance. And we're only doing about 50% because I don't want to blow out your ears. You hear like there's a couple frequencies that are standing out there. It sounds a little bit different, actually. It's a different sort of timbre to it. So here's it again. And with the resonance. Kind of has that kind of alien-esque robotic sound from the 80s. But that's essentially what we're doing is we're boosting, if you take this as like a low pass filter, right where the cutoff point is, we are boosting those frequencies and then cutting off afterwards. So that's what the resonance knob does. And this filter has a few different things that we can add as well. We can add a little bit of drive into our sound if we want to. A little bit of distortion. And we have a couple other features that we'll get into in a second. So let's get back to where we are. So this is the amplifier, which is where it's going to go after the filter. It's going to go into the amplifier next, which is going to be subtracting amplitude over time to sculpt the sound in terms of like character. So right now, this is how I have it set up. And you'll notice that the attack and the release are not all the way down. That's because if they were, we would get very clicky sounds whenever we started the note and ended the note. So we have a little bit of a cushion to prevent clicks and pops, prevent that from happening. Just kind of a precaution. So how do we use this? So right here we have the attack. So you'll see that the amp attack is defined right here in milliseconds. And the more that I raise it, the more milliseconds we get to the point where we're starting to add actual seconds. So we can go all the way up to 10 seconds. So what does that mean again? Well, this is how long it takes from the synth to get to its quietest point to its loudest point. How long is that attack? How long does it take to get from nothing to where it is at its loudest? Right now, we have it set, one sec. Right now we have it set to about 1 millisecond. Let's actually make it 1.4 milliseconds, which is pretty fast. So that means that we're going to hear it immediately. We're going to have a nice quick attack on our sound. Plays immediately. Immediately as we get the sound. If you ever wonder when I start pressing the key, you can even look at this note right here, this little light right here that'll say when I'm pushing down the note. Or you can look up here to see which note I'm pressing, which would be C. I know it says A, but that's just what key I'm pressing the keyboard. It says C, as you can see from the keyboard layout. So I'm going to play the note, and it's going to have it's just going to play immediately. So it takes 1 millisecond to get from its quietest point to its loudest point. What if we make that a little bit longer? Let's say 500 milliseconds or half a second. It takes a little bit of time before it gets to that loudest point. It's like it's fading in. So let's say what happens when we make it like three seconds. So this is your attack. This is how long it takes for the note to get to its loudest point. How quick is that attack? Is it immediate, or does it take 10 seconds? You can see the amplitude of the wave getting higher and higher until it reaches its maximum. So that's the attack. So that's how quick the sound is going to respond to you giving it an input. Next, we have the decay. Now, the decay is not going to mean anything unless we do something with the sustain. So let's talk about the sustain first. The sustain is at what point where's the volume going to be after the attack? Now, if you want it to be at 100%, so where the attack is, you just have it at 100%. So wherever the loudest point is for the attack is going to stay there. But what if we say that we want it to be half as loud as the attack? That's where the decay comes into. So the attack is going to be at its maximum loudness. So it's going to go from its quietest point to its loudest point. But it's then going to decay a little bit. So this is going to define how long is that going to take. So let's say that that's going to take about a second so that you can hear it over time. And once it gets to its loudest point, we want it to go to about 50% volume of where it originally hit. So what does that sound like? So it's going to hit immediately and then take about a second to reduce to its 50% volume. So what is that going to sound like? Well, it's going to be at its max volume, and then a second later, about half volume. There you go. So it works. So it immediately attacks, and then over the course of a second, reduces it to 50% of that volume. So the decay is determining how long is that. So if we want it to be a shorter amount of time, we can say like 5 milliseconds, then it's going to take 5 milliseconds to get from its loudest point to 50%. You can't even really hear it, but it kind of sounds a little clicky. Let's make it a little bit longer so you can hear it. So you notice that's kind of sounds accented. It's a little bit exaggerated accent, but you get the point. It has a big attack and then pulls it back a little bit. So let's say that we want it to be reduced to like 17%. Well, that means it's almost going to completely go out, but it'll still be there after the course of, let's say, 3 seconds. But it's still there. We're still getting signal. Even if you can't hear it, we're still getting signal. So let's say we only want it to reduce a little bit. Let's have like a little bit of bite on it, but still have a nice fullness to the sound. Let's have it reduce after half a second. You might not be able to hear it, but you can see in the oscilloscope right here that it starts its amplitude around here, but then quickly goes down. It gets smaller. Let's make that a little bit more exaggerated. See? So the attack is how long it's going to take to be attacked. So how long it's going to take to get to its maximum volume. The decay is how long it's going to take to get from its max volume down to the sustain volume. The sustain is going to be the sustain volume, so how loud is it going to be? Next is the release, which is also determined on time. So attack, decay, and release are time-based. Sustain is not time-based. Sustain is amplitude-based. So where is the amplitude going to be after the attack and the decay? And then the release is how long it's going to take to release. So let's have our no decay, full volume sound. So it has, so quick attack, no decay, and it's staying at 100% for the sustain. Let's have it fade out. And you'll notice when I let go of the key from the light here and the key, me letting go of it there. And you can already hear it right there a little bit. So let's say it takes about a second after I let go of the key to fade down to nothing. Seems like it's a little bit longer. But you can see it takes some time to be reduced in volume. Let's actually exaggerate that and make it 5 seconds. So let go now. So you can see it's kind of exaggerated even from here, but this is how long it's going to take to release from the point where you let it go. So if you want it to let go immediately, then there you go. Or if you want to give it a little bit of a tail, you can determine how much of that you want here. So some things that you can do with this is you can have, let's say, we're not going to mess, if we just want to work with the attack and the release, we can say that we want it to fade in, like take a second to fade in and a second or so to fade out. Then we get this nice pad kind of sound. Well, I can't play a chord, but you get this nice soft kind of whoosh of sound. It's a very long attack and a very long release. Another thing that we can do is we can create what are essentially like plucks. So, and we kind of already worked with this a little bit. So let's say that we make our amplitude about 50% on our sustain, and we have a very quick decay. So it's going to hit our max point immediately, and then it's going to decay it quickly and go back to this. So then we get like these nice plucks. Or even if we reduce the volume even more, to essentially nothing, let's reduce that even more to see what we can get. You'll notice it's not even sustaining after I play it. So I'll hold down the note and it's just done. But we get these nice little plucks. And we can reduce, we can mess around with other settings as well if we wanted to. But this is essentially your amplifier. This is your amplifier envelope. So this is your ADSR, your attack, sustain, decay, release. There's a lot of knobs that I'm not going to be going over because they don't really have too much leeway over like what goes on. So if you want to determine like the velocity of something, you can also do that here. That's not a universal thing. So I'm kind of avoiding the things that are not really universal. So after it goes to here, it's going to go to the amplifier and it's going to go out. It's actually built into the amplifier here. So that's the synthesizer. We have 2 oscillators, a filter, and an amplifier. You notice we have our modulators here. So our signal, as you can see, just goes straight through here. So it's going to be voiced through this section. We'll talk about this in a second. Made into a signal from the oscillators, filtered, and then amplified, and then we can go through effects. So if we want some chorus or delay, we can add that in there too. We're not really going to worry about the chorus and delay right now. We're just going to talk about the main things right here. So next we have the LFO and the envelope. So the LFO, or the low frequency oscillator, is another oscillator. So it's just like this, but it generates a low frequency. Who would have guessed? But what we can do with that low frequency is we can say, well, what shape do we want? Let's make it a sine wave for now. And you can see that both of these oscillators, or both the oscillators and the filter, have an LFO knob. And that is going to be the amount of the LFO that is going to be sent. So you can think of this as like the amplitude of the LFO, of that signal that's going to be sent to here. So what does the LFO do? Well, take a listen. So if I boost up the LFO amount to maybe about 50%, we can see what it does to the oscillator. So you can hear that this LFO is at a very slow rate, but it's a sine wave. So let's raise the rate of it to about 1 hertz. So it's going to modulate, it's going to go through a sine wave cycle once every second. And what this is doing is it is modifying the pitch. So this is connected to the pitch of the oscillator, and it is changing over the course of a sine wave higher or lower pitches. And we can define how much of that pitch change we want here. So if we want it to go crazy, we can go full amount. It would sound like this. But, you know, you might not want that, so you can probably dial in a little bit. But what can you do with this? Maybe you can create a vibrato. So let's make it very subtle, a very subtle pitch change. Maybe a little bit more. Maybe not that much. Maybe a little more. And we'll just keep it there to see what happens. But vibrato isn't usually that slow. So this is the rate. This tells us this is essentially the frequency of this oscillator, or how fast it's going. So let's make it a little bit faster. We kind of have a little bit of a vibrato. I couldn't remember what it was called. You can go crazy with how much you want to go here. We'll go insane with it. That's an interesting sound. But essentially what we're doing is we're modulating the pitch. And we're modulating the pitch at a rate of about 4 times a second, so 4 hertz. And we can decide if we wanted to go a little bit or a lot of it. Or maybe just in the middle. Or maybe not that much. We get a little bit of that vibrato sound. And we can change the way this oscillator operates too. But if we make it a square, it's going to go back and forth between the two values. So it's going to go to its highest point and its lowest point. So in this case, since it's the pitch, it's going to go between the highest pitch and the lowest pitch back and forth. So let's do that once a second. That sounds like a siren. But we can also change what those pitches are here. I'm going to make that a very subtle pitch change if we want. You can barely even tell it there. So that's going immediately back and forth. But if you want it to like flow, you can do that. So this is only controlling the pitch of these oscillators, and you can make it whatever sound you want. But we're just going to work with the saw wave because why not? So that's essentially what the LFO is doing here. Let's turn off the LFO by putting it to 0 here. We'll reduce the rates and put it back to a sine wave. Let's see what it does with the filter. So with the filter, we notice we have an LFO knob here. So how does it affect the filter? Well, what it is it's going to be essentially doing this. It's going to be modulating the frequency where that cutoff frequency is on the filter. And you can see that I'm kind of doing that on my own here. But instead of me doing it, let this thing do it. So let's do once per second. So it's going to be 1 hertz. So it's going to be 1 time per second. And let's just have it go about 50%, and we'll move it down here so we can hear it a little bit better. So what we're hearing it do is essentially this. It's moving this knob. So we have this controlling this knob. But instead of me doing it, I'm going to let the computer do it. I can say how much I want that to do, like how much of that frequency I want to range, how many frequencies I want it, like the range of it to be. So I can increase the range of frequencies here. Or I can increase the speed. So let's make it like 10 times a second. We're already getting some interesting sounds here. And this is only a mono synth. We're only working with one voice and one oscillator. So we can really, work with whatever we want here. Let's add this resonance back in to see what happens when we do that. Because remember when we were sweeping through the frequencies with the resonance, it sounded like this. It had that enunciated frequency right at the cutoff point. Let's see what that sounds like with the LFO. We're already getting some interesting sounds. Let's increase that frequency pitch. So there's a lot of things that we can change here. So that's essentially this synthesizer. And we have the envelope here, which we can do the envelope to whatever we want. So if we want the filter to react to the envelope. So remember, the LFOs are going to be a constant effect. So the rate is going to be forever constant. As long as I hold down the key, it's going to do this. But let's say if I want the filter to react in a certain way, once I hit the key and only once. Remember, that's when the envelope comes in. We have our one-shot events with the envelope. So let's say that we want it to get to the frequency that it's at over half a second. Let's turn off the LFO. And let's say we want it to decay over the course of half a second and have it sustain at about there. Of course, I need to turn on the envelope. So it's going to start at the peak here. Remember, it's going to say how long it's going to take to get to this peak. So, quick attack. And this is essentially going to be doing that. Let's have it decay over a second and have it go to about, let's have it reduce a lot, and the filter will be quick. It works the other way. My bad. So it'll go up from this point. So essentially it's going to go. So from at what point, my bad, I messed this up. So at what point is it going to go from the frequency that it's at to its maximum frequency, or to the highest frequency it gets? So at what point, how fast is it going to take to go from here to here? We determine that with the attack. Remember, how long is that going to take? So let's say that we want that to take, we'll turn the rest of these off for now. How long is that going to take? How long is that going to? So it's going to, let's say that we're going to start here, and that's going to take about 2 seconds to get to its max. So it got about 2 seconds. Let's say we want it to decay a little bit, take half a second to decay, and we want it to go to about its 50% value. See? And then we have the release. How long is it going to turn? How long is it going to take to release on that? So let's put it right there. So there. So that's how we apply the envelope to the filter as well, and we can determine how much we want by doing that. So if we want it to be a small effect, we don't have to add as much, but if we want it to be a great effect, we can do a little bit of that. Let's say we want a pretty quick attack, and a quick decay, and oh, sorry again. Quick attack and a quick decay. Have it not really come back down that far, and then release after 3 seconds. There we go. So that's the envelope and the LFO. So this is a very basic synthesizer, as you can see, but it has all of the elements that we talked about. And let's talk about the voicing tab here. So this just kind of has different parameters here. So we have a pitch wheel. Let's actually turn off all of our effects here, all of our modulators. So here, this will modulate the pitch. This is a pitch bend wheel. And we can say how many semitones we want it to go by. We can have it go all the way up. Like, how far can this go? Up 2 octaves. So we can have a pitch mod wheel if we want, but usually that'll stay at 2 semitones or 1 whole step. And then we have our mod wheel here, which we can attach to the filter or the LFO to say how much of that do we want. So that's also an option that you have. Up here we have a few other options. We have retrigger. So you'll see this a lot on different synthesizers. So essentially what that means is this whole system going to re-trigger itself? Is it going to run it again? Or are you going to run it through all these things whenever you play a different note? I have it so that it's saying, yes, it will. So you notice it'll go through the filter and the amplifier every time. If I turn it off, then you're going to get that, and I'm going to enunciate this a little bit. So you'll notice that the volume is now here, but if I play different notes, it's going to stay there. If I put on retrigger, it's going to re-trigger the amplifier every single time. Or it's going to re-trigger the whole system, because I'm not even using the filter really, but it's going to re-trigger the whole system. If I don't have it re-trigger, it's just going to act like these notes are within the sustain. That's something that you can do. I like having the re-trigger on, but there might be cases in where you want it off. It's all just depends on what you're doing with what's going on. And of course, we have this option that a lot of synthesizers have. And since this is a mono synthesizer, of course, this has this option. Excuse me. This is called portamento. This is a musical term that basically means glide. So sometimes you'll see glide or portamento. And that's essentially when you have a mono synth or a synth put into the mono mode, you can have your notes glide between each other, and you can determine how much you want them to glide or how long it takes with this little knob right here. So if I play the octaves here, you'll notice that I'm going to hold down this bottom octave the whole time and then play the upper octave, because it's a mono synth that can only play one at a time. So what if I add a little bit of glide or portamento in between it? You'll notice it kind of like scoops up to the next note. Let's add a little bit more. And if you were really crazy, you can add it like 100%. But usually what you would use this for is to add a little bit of glide in between the notes, usually around like maybe around 30 to 40%. Maybe that's a little much, but instead of it being so like robotic, add a little bit of glide in between the notes. Maybe a little bit more. I can even hear that effect even more with the re-trigger off. A little bit more. At this point, it's not really musically useful, but if you want to use it that way, you can. So this is Monotone. It's really a Reason rack plugin, so if you want to use it, you have to use Reason. But there's plenty of synths out there that are laid out, simply like this. So the next thing I want to show is a different synthesizer that's also a subtractive synth, and that's Subtractor. I'm also going to reset this device to make sure that that's where I want it to be. What else have I got to fix? Change some things. Reset the filters. And there we go. You'll notice that we start here, down here with the saw wave again. I'm going to turn up the volume a little bit. we start here with the sawtooth wave, but you'll notice it's backwards. It's backwards from what it was in monotone. So over here, we have those same parameters that I literally just showed. And again, initial patch as I reset it. We have two oscillators here. So these are the oscillators. We have oscillator 1, oscillator 2, and we have a noise oscillator as well. There's a few more parameters that we have with these oscillators right here. You notice that we have phase. So we have the option of changing the phase of this particular thing. So if we have it like this, I don't actually know. I'm just going to bypass that. I don't really use this too much, so I'm not really going to worry too much about it. But if you're wanting to learn more about it, you can go ahead and do so. I don't personally use it that much, but you can see that this synth here also has the 4 basic wave types. It's actually got a lot more, interesting waveforms if you want to use them. But we're going to stick with the 4 basics here. Actually, I'm probably just going to stick with the saw one because that's consistently here. But this also has a few more parameters in terms of octaves. So again, this is our octave control. We want to have a higher octave or a lower octave. We can choose that right here. But we can also tune it in terms of semitones. So here's our C. Tune it up again. So you'll hear that it's going up by semitones. And you might ask, well, why would you want to do that? Well, we'll get to that in a second. And then, of course, you can tune it in terms of cents. And you can tune it. And this is like very fine tuning. So if you want to raise it 6 cents, you probably won't hear the difference unless you have perfect pitch. But you can raise it by 50 cents up or 50 cents down, which 100 cents is 1 semitone. So this would be like half a semitone. Call these quarter tones if you want. Is that right? I don't remember. But we have a second oscillator here, which we can turn on. Then we have a second oscillator. And we can make this oscillator, whatever waveform we want. Again, we have our mixer is just a mix knob where we mix between the two. So over here would be oscillator 1. Over here would be oscillator 2. So showing that. So you have that option as well. But we're only going to use one oscillator for now. And then we have a noise oscillator down here, which sounds like this. Sounds like noise. And we can say, we have a few different parameters here. How loud is that noise compared to the rest of the synthesizer? So if we have our synth here, how loud do we want that synth? How loud do we want the noise to be? How much of that noise do we want in that signal? I'm going to turn off this oscillator for a second so we can talk about. But we also have color. Remember we talked about different types of colors of noise. You have the option of switching between different types of color. So as you go down, it's definitely like more brown, and up here is definitely more white noise, or maybe probably blue. Maybe, I don't know. It's definitely pink right here. And then here, you can actually determine how quickly do you want the decay, how quickly do you want the amplitude to decay. So like little NES hi-hats here. Now we're just getting into clicks. You probably hear my keyboard more than you hear the synth. But we do have the option of adding a noise oscillator if we wish. But we're going to go back to our sawtooth wave here. Now, again, we're going to move over to the filter. So the filter is the next part of this. Now, this is kind of the same thing, but we can determine which type of filter we want. So let's go back to our low pass filter. This is low pass 12, which means that it's going to low pass at 12 dB per octave. So that's how much is it going to cut off? Is it going to be a very slow slope, or is it going to be 24 dB per octave, which is going to be a very steep slope? We're going to stick with 12 for now, and you can hear that right here. in the frequencies, just like you did before. And again, we have our resonance knob here as well. How much resonance do we want? So much the same. So I'm not going to go over that too much here, but I'm just showing you that all the same elements are on different synthesizers, even if they look differently. You actually have a second filter here if you want. You can connect the two, but I'm going to leave this filter off, and I'm not going to link it, obviously. That's your filter. You have the filter envelope again, so you can determine, how quickly do you want the filter to do its magic. Again, I'm not going to go over that too much here. And then we have our amp envelope. Again, same exact thing. Say if we want like a longer kind of sound. But the thing about this synthesizer is that it is a polyphonic synthesizer, which means we can play multiple notes. I'm actually going to turn it down if I'm going to play chords. So we can actually play, multiple notes at once. So if we wanted to have nice loving pads like I have always been talking about here, actually going to keep that there. So you can really shape the sound with that as well. So again, you have all the same things here where you have the oscillators going into the filters, going into your amp envelope, and you have the filter envelope, and you also have a mod envelope here. You have your LFOs here too. So the LFO, you actually have two here. So you actually sync how quickly the LFO is to your project if you're using a DAW. So if you have it go, you can have it go to like quarter notes or eighth notes or eighth note triplets or 16th notes, whatever you really want. You can actually have it go in time with your project if you want it to wobble at the rate of your project. But I'm just going to keep it in terms of just free roam it here. And we have different types of oscillators here that we can use for our low frequency oscillator. We have triangle, saw, a reversed saw in the other direction if you want it, a square, kind of random noise, like kind of jumping around randomly, and then just random flowy, sort of random, like back and forth, like a square, and then just random back and forth, like a sine wave. So we don't really have a sine wave here option, but what we can do is we can also determine what we want to be oscillated from here instead of having to go into the different things and move an LFO tab. We can actually determine it here. So if we want oscillator 1's frequency to be modulated, we can set the rate to around there maybe, and then say the amount there, and we can have the pitch of the oscillator modulated. Again, much of the same. We can increase the rate of that. Sounds kind of like a thing from an NES. Let's see how far we can take this. We can say how much of that do we want to happen. This is going back and forth from low to high frequencies. We're already getting into kind of like dubstep-y kind of sounds, but that's really what the LFO is. And we can just do oscillator 2 only if we wanted to. We can mess with the filter frequency. So filter frequency over here. How much of that we want to happen. Determine where it starts too. And so on. And we have a few other things down here. We can actually modulate between the mix of these two oscillators as well. So we can have it go back and forth between a saw and a square wave if we wanted to. Let's turn on both. Let's turn on the other synthesizer. How about that? So you can see it's modulating back and forth between the two. We can have that change like this really fast if we want to, or gradually over time. There's different options that we have. We have an envelope here, which we can do, again, put this to wherever we want. So we can say that we want it to go to oscillator 1's pitch. Turn off the LFO here. It's not really going to do too much, but if we change around the parameters a little bit, we can modulate the pitch. We can also modulate the mix between the two here, again, if we wanted to. We can't really mess with the filter here because the filter has its own envelope, which is right here. So if we mess with this around, you can also inverse it if you wish. If you want to view it from a different angle, you can do that with any of these except the amp to make it whatever you want. Really just shape the sound however you wish. You can mess around with it however you want. So again, all the same elements are here on this synthesizer. And most synthesizers, you'll see these basic elements: oscillators, filters, envelopes, LFOs. These are the main things that you will see, and they will be somewhere. I guarantee you they will be somewhere there. You can find them. But how it's going to go is it's going to go oscillators into the mixer, mixer to the filters, filters to the amp envelope or whatnot, and then out. And then, of course, you have these other things here that can modulate these other parameters. Again, over here, you have your basic synthesizer's controls of like retrigger, or you just want it to be legato. So again, let's reset these parameters real quick. Sounds like it could be like a dog barking. I don't know. I got like a cartoon dog barking or like an Animal Crossing kind of sound. I don't know. Sounds cute. But what you can do is you can say how many voices that you want in there, or you can have the retrigger on. So every note is gonna retrigger that system, or you can have it legato, so it only triggers once. This is a bad example to set up with the thing. I'm actually gonna let me reset the reset the synth so you can hear it here. Actually, this might. So you can hear the difference between them. And here we have our portmanteau, which you'll notice. Oh, it's still. That's weird. It kind of does work a little bit. Usually, it doesn't really work unless you set it to have only one voice. So if I set it to one voice, it's much like the mono synth before, but now I can set it to be 2, 3, 5, whatever you want. And you can make it, these not, you can mess with these around as well. This is not really what I'm here to talk about. These are like your own personal performance aspects as well. And I kind of went over this a little bit, but we're gonna stick with 8. And this is, again, another basic subtractive synthesis. So again, subtractive synthesis is we're taking a very rich waveform and we're subtracting away from it either in frequency or in terms of amplitude. So that's subtractive synthesis. Now, if you remember, we have one other form of synthesis to go over, and that's additive synthesis. As I fix that real quick. So additive synthesis, we're going to talk about this man right here, Joseph Fourier. He was a French mathematician back in the 1700s, 1800s. And he created the idea of the Fourier series, which I talked about last week, is the idea that all complex sounds are made up of combined sine waves. So sine waves combined together create different sounds. That's where you get the idea of harmonics. And that's basically what we were doing when we were working with the saw waves, is we were taking away its harmonics. We were subtracting away those harmonics. Additive synthesis you can think of as the opposite of subtractive synthesis. So instead with subtractive synthesis, where we start with a very harmonically rich waveform and pull those harmonics away from it to sculpt the sound the way that we want it to be, additive synthesis is basically building a sound from the ground up, sine wave by sine wave. And if you think about it in terms of, one second, let me do this real quick. So if you think about it in terms of, what is physically possible, that doesn't really sound like it's physically possible because, a lot of waveforms have, infinite waves. They're just being reduced in volume over time. But there's a lot of different creative ways that you can, create synths by adding sine waves one to the other. And I want to end this rumor right now. If you put a few oscillators together and combine their different wave shapes together, that's not additive synthesis. Not really, anyway. Not really in the way that most people think of additive synthesis. So how are we going to be able to create sounds just by using sine waves, just by adding in the sine waves that we want? Well, we can base things off of currently existing harmonic shapes. So this right here is an organ. This is kind of what an organ would sound like in terms of its harmonics. And if you think about it, patches or presets in a synthesizer are just numbers. They're just basic ones and zeros data. So that's not going to take up a lot of information. And it's not going to take up a lot of memory. And if you go and look at these like very expensive sound libraries, they are like gigabytes, like hundreds of gigabytes huge, because they're filled with samples, because they record things, all the different notes at different velocities and their highest quality possible. That takes up a lot of memory. With additive synthesis, you can essentially sine wave and harmonic by harmonic, sine wave by sine wave, recreate an actual sound. And it's not going to take up that much memory because it's just data. It's simple data rather than audio files. So additive synthesis is a very new concept, by the way. Well, kind of. It's more being used musically a lot more now. So if you've ever went and saw that, you had this piano library that was hundreds of gigabytes large, that was a couple $1,000s, and you're like, wow, that's a lot of room to fit on my computer. But then you find a piano synthesizer that sounds basically almost exactly like a piano, but it's only like 40 megabytes big. It's doing this. It's doing additive synthesis. It has the data of all of the harmonics of what a piano would be, and it's just recreating that sound instead of playing a sample. It's all numbers. It's all ones and zeros. It's all data. It's not actually working with the audio files. It's creating its own thing. So with additive synthesis, you can make whatever sound you want as long as you know what the harmonic patterns of things are. So again, this is what a harmonic pattern of an organ would look like. You can recreate that by adding sine waves in one at a time. Now, the next question you're probably asking is, why would anyone want to do this? And it's just to, be able to make the sounds from scratch instead of recording stuff. The next question you're probably asking is, how do you do this? Do I just take 11 synthesizers and just set them at these different values? No, you don't have to do that. There's some additive synthesizer plugins out there. What I'm going to go over is not considered an additive synthesis plugin, but it does have additive synthesis capabilities. And believe it or not, that plugin that we're going to be using, I go back to Reason here, is going to be Serum. I bet you all are very familiar with Serum. So Serum is what most people would consider a wavetable synthesizer. So wavetable synthesizer. And what essentially that means, and we'll go over wavetable synthesis because I actually want to use Reason or Serum, sorry. I actually want to use Serum legitimately next week, but what you can do is you have this wavetable here and you shift through the frequencies here. And we'll get into that, next week. But this week, I want to get into additive synthesis. So if you go right here to this little pencil tool right here, you can actually access Serum's additive synthesis capabilities. So from what I've explained of additive synthesis, it probably sounds like there's a lot of math involved. And there is. There's a lot of math involved. So I'm not going to, really overload your brain too much on math terms here. But what we have here at the top is the harmonics. Each of these are a harmonic. So right here is the 29th harmonic, first harmonic, 14th harmonic, so on. And right here is going to be our resulting waveform. So let's take a sine wave and put it right there. So we have a sine wave at 100% volume. So this is the volume. This is going to be how loud it is. A sine wave at that volume, it's going to sound like this. Sounds like a sine wave. What if we add another frequency on the 25th harmonic up here at 50%? Well, this is going to be our resultant waveform, and you can see that we have that sine wave, which by itself looks like that, and we're combining it with this sine wave, which looks like that. So it's one oscillation combined with this many oscillations. That sounds like this. And that just sounds like two sine waves. But what we can do is let's see if we can try to replicate all our different basic wave shapes. And I'm not going to go in depth here, but like if we remember, our sawtooth wave is all the harmonics, but they're inversely proportional. So 1 to 1 would be 100%. Second harmonic would be 50%. Third harmonic would be 1/3. Fourth harmonic would be 1/4. We get there. This might take a little bit of time. And you can already see it's starting to go closer to that square shape. Fifth harmonic would be 1/5. Should be 20%. Sixth harmonic would be around here. As I get closer and closer, and if I sat here all day and went up here, I would eventually get, a square wave. But right now, I have a sound based on just adding waves together, adding sine waves together. So, like I said, additive synthesis can be very math-based. You can even see down here, there's a thing here that says enter formula. So what you can actually do here is you can enter in formulas. So the first thing I wanted to show is this. This is a saw wave, as you can see, because it's going to go up and then immediately go back down. So think of this as one cycle. It's going to go up and then it's going to immediately go back down to this point. And you can see right here, it says X. Think of this as algebra, actually. If I write, let me reset this to be a sine wave, or just literally anything else. If I write down here, a basic algebraic equation, y equals x, I get a graph. So what does y equal x? Well, it's a line that has a slope of 1. And if you can see, that crosses at the point 0, 0. If you can see that, look at that. We have a graph. So what are some other things that we can do? Well, what if we typed in y equals sine x? Actually, let's not go that complicated. Let's go y equals minus x, negative x. We get a negative slope here. Again, this is basic algebra, but we're using that. We're using, one sec, y equals negative x to create waveforms. And that waveform is going to be within this box here. So whatever's in this box is then going to be repeated again. So it's not just one line going down. It's going to be this line repeated over and over and over and over again. So let's try another equation. Y equals sine x. We get a little bit of what a sine wave would look like. Not perfect, because if you notice that it stops here, and that means it's going to go whoop, back down and go to here. So why does this do this? Well, sine x, it just goes to the top with 1. So the top would be 1, the bottom would be -1. And our window just isn't big enough. Our window isn't big enough. That's just how it is. So this is what it looks like, essentially, on the outside. It's how it's just going to loop this over and over and over and over again. Our window just isn't big enough. And there probably is a way to change the size of the window, but I wasn't able to figure that out. So essentially, we can do equations here, too. And I'm actually going to go, and this has a bunch of built-in equations for us. And the first thing that I want to show, if I can find it, might be under singles. Where is it at? Harmonic series. So as you can see here, this is going to represent all of the harmonic series. Think of these as the different harmonics. So we have the fundamental frequency. We have the second harmonic, third harmonic, fourth harmonic, fifth, sixth, seventh, eighth, ninth, 10th. And we can have all these together. We can pick which one we want and how much we want to work with that within our synthesizer. So another thing that we can do is going to show you, where's that? Sine overdrive. I'm going to go all the way to the front here. So you notice we have a sine wave here. Now, what happens when we keep adding harmonics to our sine wave? And I thought that when this showed it, it showed it with the harmonics here. Well, maybe if I go over here, it'll do it. But you can see as we go over at the end, we have our square wave. I thought it showed the harmonics. Ah, that's not good. Let me see if I can reset it here, and maybe it will do its thing. Huh. I thought it would show the harmonics up here, but silly me, it's not working in practice. It worked in testing, didn't work in practice. So yeah. So but we have when we're adding frequencies, we get that as well. Actually, maybe it was this. Ah, there we go. There's our frequencies. That was what I was looking for. So you can see this is essentially, and if I zoom out, this is adding in all the different frequencies of a square. It literally just has them there for us. And if we play it, we get that sound. So yeah, we have that option as well to type in, whatever things. And we have presets here. And sometimes, when you find presets, you can, do those. But let's actually do this in practice. So what I'm going to do is I'm going to reset this here. Or I should probably, let's type in y equals x again. So we can reset. And I think that should reset this. No, it doesn't. Oh, no. Might have to reset Serum here. Let's just reset. I might just have to reinitialize the plugin. Reset device. Open it back up. All right, perfect. So what we're going to do is we're going to take that organ frequency chart and we're just going to build it ourselves, So I don't have it to show on the screen, but I have it next to me. And we're just going to work with the first 11 harmonics because that's all it shows on this graph. So according to this graph, this should be the harmonic response to an organ. So our first frequency is going to be the fundamental frequency, first harmonic, and that says it's going to be at 60%. 60%. That sounds like this. Sounds like a sine wave. So the second harmonic is going to be at about, say, 42. So 42%. That's going to sound like this. Already kind of starting to sound like, electric piano. Next, we're going to add the third harmonic at around 29%. And I'm just eyeballing it based on this chart here. Next is going to be the fourth harmonic at around 32%. So notice it goes up a little bit, actually. Next is going to be that was the fourth one, right? So this is going to be the fifth one. This is going to be at 30%. Next one is going to be the sixth, which is also at 30%. I'm just playing a C major 7 chord, but I can make it lower too. Next is going to be seventh harmonic at 25%. Next is going to be the eighth harmonic at around 8%. I'm not going to have too much change here from now on. The ninth harmonic is at about 1%. 10th harmonic is about 5%. Maybe, actually, this is probably at like 6%. This one's at like 5%. Again, I'm just eyeballing this here. And this one, and the 11th harmonic, which is at 4%. Again, these aren't going to change it too much, but we kind of have an organ sound going for us. You know, just working around a little bit. It's not perfect because we don't have, you know, a very complex, you know, we're not working with a lot of frequencies, but we do have something that kind of sounds like an organ. And that's essentially what this is going to be. And with this here, we have a lot of options in terms of, you know, messing around and creating our own waveforms as well. Like we can create, you know, just really mess around here and just kind of make whatever sort of waveform we want. You know, these different shapes as well. You know, make whatever you want. And but you know, you get the point. Let's make a weird square wave right here. And you can just kind of do that here. This is not really additive synthesis. This is kind of messing around with what you want, but you can add in whatever formulas you want. And do note that not every formula is going to work. So if you like type in y equals 2x, that's, or sorry, y equals 2x, that's not going to work because it's out of range of the thing. Because you got to really work with, you know, what you can, but you don't even really need to type in y. If I just type in x, it's just going to make it that. If I type in negative x, so I just like typing in the y. So that's an option that you have. But this is additive synthesis, where you're adding in the frequencies, whatever frequencies you want. And people have created more, you know, better synthesizers to work with this in, like Reactor. Reactor is really popular for additive synthesis because you can just add however many oscillators you want and just really work them together like that. I'm not going to go over Reactor. I wish I could go over Reactor in this series, but or in this class series. This is a YouTube channel now. I wish I could go over in the series, but I don't really have the time or the options to be able to do that. So yeah, that is additive and subtractive synthesis. These are I would say subtractive synthesis is the basic, but additive synthesis is more complex. Not really a lot of people are doing it, but you know, if I say this is subtractive synthesis, people are going to ask, well, what is additive synthesis? And this is what additive synthesis is. And you have the option to do this if you're, you know, more into one sec. If you're more into, you know, like the math behind all of this, if you're more into the physics, into the trigonometry, if you really want to get into it, you can. You just start typing in these complex equations like this. Just type in these complex equations with sinusoidal functions and pi and all this. Like you can create, you know, whatever you want really. Create your craziest waveforms. Do whatever you want with your math. Go crazy with it. But yeah. This is additive. This has been additive and subtractive synthesis. So again, subtractive synthesis is starting with something that is very harmonically rich and subtracting from it. Additive synthesis is starting from the bottom and just adding in those frequencies wherever you want them to create the sounds that you want. So next week, we're going to be going over a bunch of different types of synthesis. So we're going to go over FM synthesis, wavetable synthesis, which is what Serum is. It's a wavetable synthesizer. We're going to go over that. We're going to go over like granular synthesis, some other random other forms of synthesis as well. Just kind of getting all of the base, all of the obscure forms, like FM and wavetable are not obscure, but we're going to talk about them, and we're going to talk about some more obscure forms of synthesis. And again, if you've been taking a look at Serum here, you can say we have our two oscillators, we have a filter, and we have LFOs and envelopes. So again, it works. Like you can see the layout of it, and it just has like 5,000 more parameters that you can work with. So that is that essentially for this week's lesson. Nobody came to this week's lesson, so I'm going to still send this out. And I understand that we're in like a whole quarantine situation. If we're not getting a lot of attention, during the time that I'm setting up for it, I'll probably just record these and just send them out anyway. You guys will still get the information. You just won't have them live. You won't be able to ask questions. But I still want to do it live if possible. And I know that some people have emailed me saying like, hey, I can't make it. There's not really any other time that I can record this stuff. So I do apologize for that. So yeah, if you have any questions about any of the videos that I've sent, do feel free to contact me. I can like meet with you one-on-one if you want to go more in depth with any of the stuff that we've talked about in any of the lessons prior to the Zoom stuff or during this, or if you just want to like talk about, sound design stuff in general. We haven't really worked too much in terms of, how to build your own synths, because that's kind of your own choice. It's like saying, how do I write a song? Well, I mean, that's up to you, really. I mean, we can give you the tools to be able to write your own music, but you have to be the one to figure it out. So I'm just letting you understand, how these different synthesizers work so that you can use them to create whatever you want. And that's going to take years to be able to find, for you to be able to have like an idea in your head and actualize it within a synthesizer, or being able to write whatever you want with a synthesizer, just messing around, knowing what you're doing. So mess around with synthesizers. I will send out with this video another video to a YouTuber that I follow that talks about a few different free synthesizers. So if you want to start working with these basic synths, if you want to start working and trying to figure it out and doing it on your own, he's gotten through, like, it's gonna be a little bit of a longer video, but he goes through like every free synth that he can find and recommends, which ones that would be good for you. So next week it's going to be FM synthesis. We're going to be talking, kind of a little bit about the DX7 and different FM, capabilities like algorithms and stuff like that. So that's going to be fun. Getting into that stuff. And then of course we'll talk about wavetable synthesis, which is what Serum is, granular synthesis, and whether other types of synthesis that I want to talk about in the time. Like here's a granular synthesis right here. How does this work? I don't know. I mean, I do know, but find out next week if you're interested, because this is all based on like inputting samples. This is kind of like a sampler kind of, but it's not really. It's a sampler and a synth in once. What? We'll talk about that next week. And next week's just going to be like a showcase of a bunch of different types of synths and how they work. So come to that if you're interested. I know, you're not required to come to this, so not a lot of people have been coming to it, but I'm still sending out the information, still recording this stuff for you guys, because I want you guys to have access to it in case, you do want to read up on it or watch the videos to learn a little bit of something. So yeah, that's it for this week, and stay safe, take care. Again, if you have any questions, email me. I'm willing to answer any or all of your questions. And yeah, I'll see you guys next week.